Hi students, today we are going to see about warning indicators. Myself was SATHISH, assistant professor in mechanical department at Aksha College of Engineering and Technology. Early warning system. An early warning system can be defined as a set of capacities needed to generate and disseminate timely and meaningful warning information to the possible extreme events or disaster, for example flood, drought, fire, earthquake and tsunamis that threatens people's life. The purpose of this information is to enable individuals, communities and organizations threatened to prepare and act appropriately and in sufficient time to reduce the possibilities of harm, loss or risk. Characteristic of early warning system. Effective early warning system requires strong technical foundation and good knowledge of the risk. But they must be strongly people centered with clear message dissemination system. Public awareness and education are critical. In addition, many sectors must be involved. Effective early warning system must be embedded in an understandable manner and relevant to the communities which they serve. Here we can see an early warning system how it works. Measurement of precursor forecast indicates catastrophic event. If it is yes, the warning is started. If it is no, measurement of precursors always search. In case if the warning is set, one set of anticipated response if we give, it is the early warning system. Agencies for forecasting. During cyclone, agencies like Indian Meteorological Department will function. During the disaster of the tsunami, agencies like Indian National Center for Oceanic Information Service will act. During disaster of flood, agencies like Central Water Commission will work. During disaster of earthquake, agencies like Indian Meteorological Department will act to give the early warning system to us. Earthquake. Earthquake early warning system use earthquake signs and the technology of monitoring system to alert device and people when shaking waves generated by an earthquake are expected to arrive at their location. For this purpose, USA California developed a machine called Shake Alert, which gives the exact time of arrival of shaking to the station. With the help of this technology, we can save so many lives and also reduce damage to the building to some extent. This is a sample image of how this earthquake shaker will work. A user receives a message like this on the screen of the computer. The message alerts the users to how many seconds before the shaking waves arrives at their location and the expected intensity of shaking at the site. The warning messages also displays a map with the location of the epicenter, the magnitude of the quake and the current position of the P and S waves. Here in this picture we can see the earthquake early warning basics. Here red color indicates the S wave and yellow color indicates the P wave. There is a epicenter fault which creates a wave. In an earthquake, a rupturing fault sends out different types of waves. The fast moving P wave is the first to arrive, but damage is caused by the slower S wave and later arriving surface waves. Second, sensors detectors are detecting the P wave and immediately transmit data to an earthquake alert center where the location and size of the quakes are determined and updated as more data becomes available. In this third stage, a message from the alert center is immediately transmitted to your computer or mobile phone, which calculates the expected intensity and arrival time of shaking at your location. For now we can see the flood. A typical flood warning system indicates a number of items including automated sensors which are placed in or beside river and reservoir throughout a designated area. Data is then collected and sent immediately to a base station or personal computer. In this way, appropriate forecasts are sent to authorities or communities of those potentially affected by the developing flood as soon as possible. Here we can see the flood warning and response. Initially, detecting are done by the meteorological monitoring, forecasting, and then threshold, and then warning dissemination, and then response, recovery, and then review. During this, preparedness is highly necessary during the flood. Solution: a wireless system manages flood or flash flood risk by providing early warning to the downstream communities and enhance cooperation between upstream and downstream communities in the shaking of flood information. This solution consists of two units, transmitter, receiver. The transmitter is installed along the river bank and the receiver is installed at the house near the river. The transmitter and receiver works functionally by when the river of the flood which occurs during the time. Solution: a flood sensor attached to the transmitter detects rising water level. When the water reaches a critical level, a signal is wirelessly transmitted to the receiver. The flood warning is then disseminated via mobile phone to concerned agencies and vulnerable communities downstream. Critical flood levels are set with the help of the local community. DART is an example for a tsunami. Deep ocean assessment and reporting of tsunami is a component of an enhanced tsunami warning system. By logging changes in seafloor, temperature and pressure and transmitting the data via a surface bio to a ground station by satellite. DART enables instant accurate tsunami forecast. The DART system consists of a seafloor bottom pressure recording BPR system capable of detecting tsunami as well as 1 centimeter and moved surface view for real-time communication. In this picture we can able to see how the DART works. The tsunameter gives the acoustic transducer by sending the surface view to the satellite. From the satellite, the tsunami warning center receives the signal. Here we can able to see the tsunameter mooring system. Here The signal flag which receives the height, and then the battery connection of the CPU system sensing devices which transmits the transducing element. This creates acoustic terminal inside the water. There is a antenna of a GOES which is connected in the transducer of each unit. It receives the RF modem, and then this converts the RF modem into the antenna signal that goes to the satellite. From the satellite, it's going to received by the station of the center. By that we can able to receive the wind, how it is flowing, how the barometric pressure is there, and then sea surface temperature and conductivity of the air temperature and relative humidity and all the data are sensed and signals are transmitted to the transmitting unit of the persons who are in the center. Now we are seeing about the cyclone. Scatterometer. Scatterometer are unique among satellite remote sensors in their ability to determine surface, wind speed and direction. Microwave was scattered by a shorter water wave, capillary and ultra-gravity waves which respond quickly to change in windows. The backscatter cross-section, the fraction of transmitted energy that returns to the satellite is the function of wind speed and wind detection relating to the orientation of scatterometer. Scatterometer actually determine equivalent neutral wind speed at a height of 10 meter above the local mean water surface, which differs from wind speed that would be measured by antennometer after adjustment to a height of 10 meter. This is the sea wind scatterometer, how this is measuring the wind by the flow of the air above the 10 meter above. By this all the natural disasters we can able to see, we can able to predict. By that we can able to get the early warning systems to make a safe environment for the people who we are living in the world. That's all for today's section, students. Thank you for listening. Thank you very much.